After finishing the 30 feet, the Mythslammers prepare to run the 60 foot. Aiden is the first runner. As you can see, the car pretty much ties him.
Hey, not bad, dude.
Huh?
Would you say that's a tie, Gio?
And Durkin with a solid 3.4.
3, 2, 1, go.
After running, Pat Gill recorded a 3.3 60-foot run. And John Hammond is the next runner.
3, 2, 1, go. What'd he get?
Hammond passed the thing at like 3.6.
A 3.6 is his time. Not too bad for a big man.
Three, come on. 3, 2, 1, go.
And John Furlow crosses the finish line with 3.2.
Hold on, man. I think you tied, son. 3.2. 3.2. That was a speedy car. Watch out.
The group will once again measure the car's solo speed, just for confirmation purposes.
Hey, ready? 3, 2, 1, go.
So let's go 3.3 because that's the middle.
Show him 3.2.
Gio, you got this? That boy Gio.
For further calculations, the scientists are going to measure the speed it takes to get to 0 to 60 miles an hour in the 2000 Jeep Cherokee.
Come on, are you having? Come on, reverse. Don't be a coward. Let's go. Come on. Start filming.
Reverse it back, dude. You got more room.
No, he's got all the way. He's got all the way to like.
On 3.
He's got all the way to Harlem.
Hey, you just gotta move your arm. There, that's fine.
You still have to control the wheel.
2, 3, go.
Your hands in the way.
These cars. Guys, stop it. Stop it.
And 12.5 is the confirmation. After a little driving and cruising around, boys head back to the lab to analyze their data.
So we just got back in from the field, and I was kind of surprised that we only beat the car by so little, because the fast twitch muscles of the quadriceps are moving way faster and twitching harder than the transmission of a Jeep. Like, I was flabbergasted by that.
Alright, so let's take a look at the numbers. So we did 2 test runs. We did a 30 feet and a 60 feet. With the 30 feet, we came up with these times. Alright, so first off, Pat Gill. Pat ran a 1.9. John and myself, my other scientist, we both ran 2.0. Now, the other scientist, obviously, John Hammond, ran a 2.5. Alright, so we have those numbers down. We obviously, we'll get back to those. Now let's go to the 60 feet. We tried our second one. Basically, because we beat the car, it was a pretty close, tight to tight, but, usually we came out on top. So we did another one, to really test this myth. 60 feet. These were our numbers. 60 feet, we got Pat Gill with a 3.3. We got John Hammond with a 3.7. And Aiden Durkin with a 3.3. Sorry about that, guys. And John Foy with a 3.2. So what did we learn from these numbers? Basically, from these numbers, we learned that through 30 feet, yes, a person could outrun a regular car, but that wasn't the myth. The myth was, could we outrun a race car? So from what I'm thinking, if we barely just beat the regular car, chances are we're not going to be a race car. but we went ahead with the regular car and tested, the extra 30 feet. Some interesting numbers. Obviously, once the car gets enough room to really start accelerating, it did beat all of us in the 60 feet. But, some of these times, some of us, like John Hammond, where is he? He had a 2.5 in another one, but, he kind of kicked it up with only a 1.2 in the second leg of it. So we learned some interesting facts. To see if this myth is really slim, we're going to have to compare the numbers. Starting off with the acceleration of a race car.
This means that an automobile's performance gets stronger the further it goes. While a human may be able to outperform a car on 30 feet, we reach our maximum potential within that short distance, while a car only continues to get more powerful, as we can see in the 30 to 60 portion of the race.
Okay, so I was helping my fellow scientists slam this myth. We're doing a little research on the acceleration of the F1 race car. So in order to find acceleration, you have to do this equation here. We're presented with a little bit of information. The average race car goes 0 to 60 in about 2.5 seconds. Okay, that's all we really know. So to find the acceleration, take A for acceleration equals the final velocity, that's the final speed, which is 60, minus the initial velocity, the beginning speed, which is 0, okay, over the time it took to get there, so 2.5. Pretty simple. Okay, so 60 miles an hour, let's plug that in. Minus 0 miles an hour. Now we have to convert 60 miles an hour to feet per second because we're traveling 30 feet. So in order to do that, you find the amount of feet in a mile, which is 5,000. What was it?
280.
5,280. And you multiply that by 60. So you end up getting 316,800 feet. Okay, you multiply and you end up getting 316,800 feet. Do the same multiplication for seconds. 3,600 seconds. Okay? Simplify that, you end up getting 88 feet per second that this car travels. Okay? Plug that in right here. Okay? So you end up getting 88, okay, minus 0 over 2.5 equals 35.2 feet per second. That means that this race car travels 35.2 feet per second. Okay? So to go 30 feet, less than 35 feet, is going to be less than a second, right? So just take 30 feet and divide by 35 feet. 35.2 feet. You end up getting 0.85 seconds. So that means that this car travels 30 feet in 0.85 seconds. Each of us running on average, we got about 2 seconds. John got 2.5, no offense. Okay, we all got, definitely nowhere close to 0.85. So in conclusion, this myth is slammed to the dirt because we can't get close to that. We may be able to beat the Jeep. We're not beating this. It's over. Slammed! Slammed!
Guys, so I don't know about you, John, but I kind of saw this one coming a little bit. I was surprised a lot that, we beat the regular car in the 30 feet. But, a race car, that's something different. How about you? What do you think?
Same. I really saw this one coming. I didn't think we could beat the race car. The Jeep, yeah, we could beat the Jeep.
That was surprising. Would you agree? I mean, I didn't think that we'd be able to beat any sort of car.
But it's a Jeep. I knew we could beat a Jeep.